Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new series on edge effects. In this clip, we show that certain manufacturing operations are very, very, very uneven at the edges. Thus, you should expect to have more complaints on the edges than elsewhere. Here we discuss examples from both the film and the paper industries. I know your time is precious, so let's get started. This is a continuation of shows covering various troubles that you or your customer might find at the edges of your web. We began this series by discussing the economic optimum amount of trim to take. I urge you to see that first show if you've not already done so, because it covers essential edge issues for anyone working with webs. In this show, we cover examples from the film industry, including cast film necking and tentered film, as well as an example from the wet end of a paper machine, all of which that suffer terribly from the edges. Cast film begins as a hot curtain of polymer coating coming from a slot die. This hot curtain falls onto a cooling and forming drum. Unchangeable physics requires that the edges neck in due to surface tension of liquids. This neck-in results in at least two defects at the edges. The first, shown in red, are skewed principal axes. We covered principal axes in my Web 101 school, so we don't need to do that here. All we need to summarize here is that results in a propensity to shear stresses and thus wrinkling when the edges are transported under normal tension through your and your customer's machine. The second is thicker edges, as explained in brown. Here, 2 inches of the edge of the die only makes 1 inch of the web width, while in the center it is a 1-to-1 ratio. That almost certainly results in edge bagginess, as explained in my Web 101 school and elsewhere. Yes, die manufacturers are well aware of this and do try to minimize edge effects by design. However, the results are very, very, very imperfect. This next example from a totally different industry paper has very similar results. Here, all we need to know is that the watery paper stock coming out of the headbox on the wet end of a paper machine tends to flow outward at the edges. The result is that the fiber orientation is not random. I do not mean the intentional MD to CD ratio that all paper makers are familiar with, that results from the drag and rush settings of wire speed. Rather, I mean the 2 to 5 degrees of outward direction of the principal axes at the edges of the paper. Fiber angle is so important that paper makers have developed several instruments to be able to measure it, including the standard tensile tester and an ultrasonic time-of-flight probe that infers moduli at various angles. In any case, the outward inclination of the principal axes at the edges means that paper is more prone to wrinkling there just due to normal tensioning in a web machine. The final example we will cover in this show is film tentering, such as used on Biax films. Here, the clips clamp on the edges of the hot web and literally drag them outward, increasing the web's width to perhaps 2 or 3 times its original width. This results in thicker edges and uncountable other edge troubles. As we discussed in several of the previous shows, the question many will ask is, why not fix the edges? Well, if that were easy, people would have already done that. However, machines are inherently imperfect, and merely improving, not necessarily even fixing, the edges cost money. That could be millions of dollars extra in cast film die design optimizations, or tens of millions extra dollars on paper machine head boxes. Of course, trimming costs money also. Of course, so do internal rejects and customer returns. Thank you so very much for joining me in this Edge Effects mini-series. Please join me next week where we will continue our discussion of edge quality challenges by talking about uneven temperatures at the edges of your web. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.